My name is Sharon Schwartzman. I'm a technical marketing engineer for the VDS-TC product. Today I'm going to demonstrate VDS-TC and 7000 using ITD mechanism, which is used for scalable, high available load distribution VDS-TC solution. The environment that will be used during the demo include the Nexus 7004, two chassis of 8 blades each, that's a 16 blades cluster, two vertical connect to both chassis in an active and failover type of configuration. Connected to the 7004 10 line cards. There are two two Nexus 2000 devices connect to the same Nexus and connect to the shared storage of the VDS-TC solution. These are NetApp E2700 series, 6 of them. Management server, the application that is used to manage the application running on the 16 blades, and 4 PBR routers, which we are simulating using Avalanche C100 traffic generators. Simulate both subscribers and the internet, the web servers, and I'm going to show you the generator UI on top of the system and the ITD mechanism. So let's start. Here in front of us we see the VDS-TC, which is the Videoscape Distribution Suite Transparent Caching Solution. This application caches HTTP and peer-to-peer traffic. Okay, see the system that I described, that was shown on the slide. 16 blades, 2 chassis, 1 management server, and 6 NetApp storages. Here you could see that the traffic flowing through the Nexus and the blades is approximately 130 gigs. Here we can see in a logical view, we can see the distribution, how the load is distributed among the cluster members, and this distribution is achieved simply by using the ITD running on the Nexus 7004. We see here that the accuracy is quite meaning we see that 5.7, 5.8 gig of traffic is shared across all 16 members. We know that the cache out, the traffic that is going out from the storage, is also evenly shared. Meaning the ITD helps our VDS-TC solution to evenly load share the overall traffic among the cluster members. On this interface, we can see the Nexus 7004. Let's look at the version. The version is 6.2.10. That's the version that we qualified for the VDS-TC solution. And as you can see here, it's a Nexus 7004. Nexus 7004 is sufficient for support VDS-TC 16 blade solution. Here we can see the ITD service configuration. On each and every cache engine or cluster member, we have multiple IP addresses and multiple IP address ranges So if we have 16 servers and 4 PBR routers, we have 10.38.201.1 through 10.38.201.116 IP addresses on the cache engines. And in order to support additional PBR routers, with up to 4. So in each group, we have a different address range. Here you can see 10.138.201 through 202.116, and same goes for PBR router number 3 and PBR router number 4. Okay, so what we essentially configure here is a node level standby. So in case the main or one of the active interfaces on one of the blades, then we set in the node level standby configuration, we set the alternative or the second virtual interface, which is configured on the same blade. Here we do the same. We configure active interface, and its standby is the other active interface. So in case one of them fails, then using ITD ICMP probe, this identifies the failure and simply directs the traffic to the standby active interface or IP. And the application can absorb this load on the same interface. So that's node level standby, and in case a complete node goes away, then ITD will identify this event using the ICMP probe again, and will apply a complete bypass. So all traffic redirected to a specific node will be simply sent back to the PBR router. Here you can see that we have a few services, ITD services. We have ITD services for each PBR router. In that, use the load balancing method of destination IP. The first interface is a unique VLAN, and subscribers relate ITD uses different unique ingress interface, VLAN 101 in this case, and balance method is source IP. So using ITD and this specific configuration, we maintain stickiness that based on the source and destination returning traffic is classified by the destination, incoming is classified by the source IP. So our application is sensitive to this kind of traffic pattern. So we configure the ITD appropriately, and by that we achieve the application needs, and also the accurate and equal load balancing. Here you can look at the ITD statistics for wire services. You can see we can see here that 3% are fed equally across this all 16 IP addresses representing traffic from PBR number 1 sent by subscribers. The other statistics, the other risk, which is internet returning traffic to subscribers from PBR router 1 from the internet, will essentially show the same thing, quite accurate load distribution, and necessarily returning the packets to the cache engine or to the cluster member through which the requests from subscribers from PBR router number 1 arrive. So ITD helps us, our solution, to better scale and evenly distribute the load. It also helps us to maintain a very complex and non-straightforward configuration. As you can see, this is the auto-generated configuration. Previously, for ITD, we had to configure it and keep it in templates, and partner and advanced services and customers had lots of challenges to maintain such configuration. So ITD helps us simplify all that. It's limited to a handful of commands, of command line commands, which is essentially relatively contained and manageable configuration. And we can see here the Avalanche parent company Avalanche traffic generator. We can see here the client side, we generate currently around 100 gig of traffic. We see that the servers, we simulate servers, so the servers currently return approximately 80 gig of traffic, and the rest is generated or returning from out of the cache. Engines pull the requested content if it finds it in the cache from the cache, and serviced by that solution is the load on the servers, and also reduces the traffic traversing across the international and sometimes the national links, and helps the service providers to maintain high quality of experience for their subscribers, and also to significantly reduce the cost of the international links. Okay, that's it for today. Thank you for your participation.